Hello everyone, this is Dr. Nandy. In this video, we are going to talk about the kinematics multiple choice questions of AP Physics 1, and this is a part 2. So before starting, I would like to request you, please go through the part 1. So in this problem, it's given that a ball is thrown and follows the parabolic path shown above. Air frictions is negligible. Point Q is the highest point on the path, and point P and R are the same height above the ground, which means this point P and the point R both are from the ground. Let's consider those are located at the same height h, and Q is representing the maximum height. How do the speeds of the ball at the three positions compare? This P, Q and R. So at the position P, if we are going to draw the force, velocity diagram, so it would be like velocity, it would be along the tangential direction, so it would be represented by Vp. That can be represented, that can be resolved into two components, so it would be like Vpx and Vpy, where this x and the y directional component, it can be considered as this is the x-axis, y-axis, and Vpx and Vpy are representing the component of velocity at the point P along the x directions, and Vpy represents the velocity component of Vp along the y directions. Similarly, when it has reached at the point Q, that is the maximum height, so in that case it will be having the only the horizontal component of velocity. It would be Vqx, and there is no velocity along the vertical directions at the highest point, since if it would be having any vertical component of velocity, it is supposed to move either up or down in this direction, in this positions Q. But as we are defining Q is the maximum height, so the vertical component of velocity at the point Q, it should be 0. And at the point R, always we are going to represent the velocity, it is along the tangential directions of its path. So at the point R, the velocity, it can be represented by VR along the tangential directions of its parabolic path, and that can be resolved into two components, that would be Vrx and Vry. Now the thing is, there is no accelerations along the x directions in projectile motion. From there we can say the velocity along the x directions at any point, it would be same. So which means we can say Vpx, velocity at the point P along the x directions, velocity at the point Q at the x directions, along the x directions, and velocity at the point R along the x directions, it would be always same. And there is certain velocity component along the vertical directions for the point P and R, but there is no vertical velocity at the point Q. That means from here directly we can conclude that velocity at the point P and R, it must be greater than the velocity of the point Q. Now from there, how we can get this velocity at the point P and R? So for that, let's take an example. One object which is thrown from the ground at a certain velocity v in the vertically upward directions. After some time, it will be come back to its initial positions again due to its gravity. So it is going to strike the ground with certain velocity, it's v prime. So now let's consider the height, that is equal to h. So from here, one conclusions we can make that if we are going to neglect the air frictions, means the air drag, in that case the velocity with which the object has been thrown in the vertically upward directions, after during returning also, it is going to strike the ground with the same velocity v prime, that would be same as v. And that we can easily find out by using any of the concept like conservation of energy in between the point 1 ground and the point 2 at the maximum height. So at the maximum height, we can say that object is having the potential energy, since the kinetic energy equal to 0, and at the ground object will be having the kinetic energy, since the potential energy will be 0. And according to conservation of energy at these two positions, that always energy would be constant. So at the potential energy, that can be defined as m into g into h, where m represents the mass of the object, g times h, that is the vertical height, that is equal to half into m into the velocity, that is v squared. So from there, this mm is eliminated, and we can say velocity equal to its square root of twice into g into h. Similarly, again, if you are going to apply the conservation of energy in between 2 and the point of returning 3, then the same expressions you are going to get, that v prime equal to square root of 2gh. or you can apply the equations of kinematics, that's also will be giving the same expression. So from there we can say the velocity which is purely depending on its height, and it is directions are different, directions are opposite, but the velocity magnitude it will be same. From here also we can conclude the same things, that velocity vpy and velocity vry, those magnitude it would be same. So you can say vpy mod of vpy, that is equal to mod of vry. So from there we can conclude, if we are going to make a comparison in between all the velocities, that means velocity at the point P and velocity at the point R, it would be same, and those are greater than the velocity at the point Q. So that is given in the options D. And in the next one, which of the following diagram best shows the directions of accelerations of the point of the ball at the point P? So any of the positions in case of projectile motions, we can surely say that it will be having only acceleration, that is same as the gravitational acceleration, and that is always exerted in downward direction. It doesn't matter at which location the object is there, it will be always having the same as gravitational acceleration, and that is downward. So the answer it would be D. So here it is given, which of the following pairs of graphs shows the distance traveled versus time and the speed versus time for an object uniformly accelerated from rest, which means the initial velocity equal to 0, and from there it is uniformly accelerated. That means the acceleration that can be represented by its delta v upon delta t, which means if you are going to consider the velocity time graph, it should be a straight line since the uniform acceleration. We have to check that where the speed time graph, the speed time graph in the first one, it's representing a constant slope. In case of B and C, those are representing the varying slope, so those cannot be the answer. So we have to analyze the options A and D. Those are representing the constant acceleration. Now let's analyze the distance time graph. So in case of the first one, the distance time graph, that would be let's consider one point here and other point here. So it's A point and other one is the B point. Now we know from the distance time graph, if we can take the delta S upon delta T, that's representing the velocity. So velocity equal to its change in displacement per unit of time. And now at the point A, if we have to find out the slope or gradient, what we can do, we can draw a tangent, and this tangent will be representing the gradient at the point A. Similarly at the point B, you can draw a tangent, and that tangent will be representing the gradient at the point B. Now from the tangent itself, we can make a conclusion that the tangent at the point B, that will be less steeper as comparison to the point A. So higher tangent means it will be representing the higher gradient, and higher gradient you can consider the angle here, it is like theta A, and at the point B, if you are going to consider the angle, that will be theta B. So at this point for the A, theta A, that is greater than theta B, which means that it's the slope at the point A that will be higher than the slope at the point B. Slope at the point A, that must be greater than the slope at the point B. And from there we can conclude that slope from the distance time graph, that represents the velocity, which means the, or you can say the distance time graph, so it should be representing the speed, which means the speed at the point A, that is greater than the speed at the point B. So with respect to the time, the speed is decreasing. With respect to the times, the speed is decreasing, means it's the retardation. And the similar calculations if you are going to do here, so there are 2 points I'm going to consider, and at the point A and at the point B, if you draw the two tangents, easily you can make a relation that theta A, that is less than the point theta B, angle which is less, which means the gradient it will be higher at the point B. So from there directly we can say this will be representing our, that D, it would be the accelerating conditions. And in different way that you can talk about that, let's analyze the equation. We have the distance time equations, that S equal to initial velocity into time t plus half into acceleration into t square. Now it's given that started from rest. Started from rest means initial velocity that is equal to 0, which means s equal to its half into a into t square, and this graph is representing the parabolic graph, and the nature of the graph, it would be represented by this way. So by analyzing the equation also, we can say that D would be the correct answer. Here in this question is given that vectors v1 and v2 shown above have equal magnitudes. The vector represents the velocities of an object at times t1 and t2 respectively. The average accelerations of the object between time t1 and t2 was, and these are the given options. So accelerations, average accelerations, it can be represented by its delta v in vectorial form, delta v upon delta t. Now the delta v, that's the change in the velocity, so it's final velocity minus initial velocity, that's representing the difference in the velocity upon final time minus initial time, so it's t2 minus t1. Now here v2 minus v1, this basically we have to find out the subtractions of this vector. So if we draw the same v1 in the same diagram v2, so that can be represented as its v1 will be pointed along these directions, and that will be representing the v1. We have to take to find out the difference in between v2 minus v1. I have to take the opposite of this vector v1. So opposite of the vector v1, that will be pointed along this direction, so it will be negative v1. Now here to find out the difference in between v2 minus v1, here basically they are asking the average accelerations of the object directions, means accelerations directions. So in that case, what we can apply, the difference in between this v2 minus v1, that can be done by doing the head to tail method we can apply. So instead of v1 at this position, we can translate this v1 at this end, so that will be representing that negative of v1 here, so that will be pointing here, that will be pointing here. It's basically representing the v2 position. So initial position is the origin, and v1, this is the final positions. If you join this, that will be representing the resultant of that, resultant of the vector. So resultant of the vector which is directed towards the north and the west, so directed north of west. This is the option D. So here it is given the velocity of a projectile at launch has a horizontal component vh and a vertical component vv. Air resistance is negligible when the projectile is at the highest point of the trajectory. Which of the following shows the vertical and the horizontal component of its velocity and the vertical component of its acceleration? So at the highest point of the trajectory. So let's draw the projectile motion. So here they have given the initial horizontal component, that is represented by vh, and the vertical component, it is represented by v suffix b. So the object has been projected with this velocity, let's say v, and it is moving like this, and that will be representing the highest point. So at the highest point, we have to find out what would be the component of velocities and acceleration. So here always we are considering, in case of projectile motions, accelerations along the horizontal directions. So here horizontal directions we are considering as x, and the vertical directions we are considering as y. Accelerations along the horizontal directions, it is always 0. Accelerations along the vertical directions we are considering always as same as gravitational acceleration, that is in downward directions, which means at the maximum point the velocity along the horizontal directions, that would be always same, because the accelerations along the x directions we are considering as 0, and the accelerations along the y directions we are considering that is equal to g. That means at the point, maximum point, the vertical accelerations, that would be g downward, and since this is the maximum height, at the maximum height there is no component of velocity along the vertical directions, which means the vy, it's supposed to be 0 here. Now let's take the options. The vertical velocity, that is 0, horizontal component vh, vertical acceleration g, that means the option D. The graph above shows the velocity v as a function of time t for an object moving in a straight line. Which of the following graphs shows the corresponding displacement x as a function of time t for the same time interval? So here we have the velocity time graph. We have to find out corresponding correct displacement time graph. So let's analyze the options. So here in the first options A, the displacement and time graph is given, but the thing is in the center positions, here it will be having the there is no displacement with respect to the time, and we know that area under the VT graph, that will be representing the displacement, and the slope of the displacement time graph, that is going to represent the velocity, which means from the displacement time graph, if we can find out the slope or gradient, that will be representing the velocity. So in between this time there is no displacement with respect to the time, which means the velocity equal to 0, but here in the diagram the velocity it is constant. Similarly, the same logic at this position, in between this two time interval, there will be the velocity, it would be 0. That means the possible answer in between C and D. Now just consider the C point. So at the C point, if you are going to consider like 2 points here, one point here and other point is some later time period. Now in that case, what will happen if you are finding the tangent? If you are considering the tangent at the point 1 and at the point 2, so by drawing the tangent, you can determine that the second tangent which is drawn at the point 2, that will be less steeper as comparison to the first tangent, and the tangent is representing the velocity here, because tangent is going to represent the slope in displacement time graph, and then that is corresponding to the velocity, which means the velocity at the point 1, that will be higher than the velocity at the point 2, which means the velocity is going to decrease in case of this one. But here we can see that velocity with respect to the time, for the initial time period, it is going to increase. And if you are analyzing the D options, here the tangent means it is continuously becoming steeper, and for the later part it is becoming less steeper, so which means the initial its velocity increases and later the velocity is going to decrease. So D would be the possible answer. So here it is given, the diagram below shows 4 cannon firing cells with different masses at different angles of elevations. The horizontal component of the cell's velocity is the same in all 4 cases. In which case will the cell have the greatest range if air resistance is neglected? So here basically we have to find out the range. So the formula of the range, that can be represented by, it is R equal to V square sine 2 theta by G in case of projectile motions. So where this V represents the velocity of projection, theta represents the angle of projections, and G represents the gravitational acceleration. Now if we substitute that all the values for the A cannon, that will be the velocity is 57.7, square of that in sine 2 theta, where theta is represented by 30 degree, and by 9.8 G. So if we calculate that, you will be getting 294.2. Similarly for RB, if we are having the velocity that is 70.7 and sine 2 theta is 45 degree, then from there we are getting 510.05. And RC, in case of cannon C, the initial velocity and the angle of projection, that is same, which means the range traveled by the cannon C, cannon C, that will be also same as the B, which means from here we can make a conclusion that range which is independent of the mass of the object. So in case of the cannon C, the mass it is given as 2 kg. Now for cannon D, the initial velocity it is 100 and the angle of projection is 60 degree. If we substitute in this formula, we will be getting 883.7, which means the cannon D will be having the higher range.